Hello and welcome to R&D Mathematics. Today we are going to talk about domain of functions. Now I told you function is like a machine. So let me recall you. If you add f of x equal x plus 1, whatever you put, let's say you put t, then what comes out is t plus 1. Now this is like a machine, the set of everything input, and we call it domain. So in simple words, everything that you can put into your machine, and actually what comes out we call it range. Now you cannot just throw everything into your machine. For example, like a washing machine, you cannot throw shoes, stones, things like that. Exactly like that, for functions there are set of things that you can put. That's known as domain. Now let's take some examples. Now let's take first simple example, f of x equal x plus 1. This is a linear function, and if you think about this, can we talk about things like this? F of negative 100, well, that's negative 100 plus 1, which is negative 99, which makes sense. F of 0, 0 plus 1, which is 1. F of 1000, 1000 plus 1, 1001, right? So it seems like we can put any number. So domain of this function normally we denote it by d sub f, all real numbers. We use this notation, O reals with double line. Now how about this? F of x equal x squared plus 1. This is a quadratic function. Still, if you think carefully, you can put any real number into that. So actually, any kind of polynomial, domain of any polynomial function as negative infinity to infinity. Now, polynomial is anything of this form, like for example, it's easy to give some example. F of x 7x to the 8 plus 5x squared plus x plus 8, something like this. A polynomial does not involve term like x does not in the denominator, only numerator, nice things like this. So for a polynomial, domain is all real numbers. Now let's take another example. How about this? F of x equal 1 over x minus 2. Now let's plug some numbers and check. F of about 5. 1 over 5 minus 2. See, we are replacing our input value by x, right? So 1 over 3, which makes sense. For this particular function, you can put everything except one number. Can you pause the video and think about what that number is? The tip is you cannot divide by 0. So 1 over 0 is not acceptable. You cannot have that. But the number we are looking for is not exactly 0, because f of 0, 1 over 0, I can replace x by 0. Because 0 minus 2 is negative 2, so we have negative 1/2, which is fine. But what if I put f of 2? Then I get 2 minus 2. Okay, now we have a problem. 1 over 0. This is not acceptable. So the domain of this function is all reals except 0. This is one way of writing it. If you think about this, except this point 0, everything to the left and everything to the right. So in interval notation, from negative infinity up to 0 without 0 union, from 0 to infinity. This is how you write the domain. Now, this brings up, how about this example? F of x 1 over x minus 2 into x plus 1. Now what you need to do, you need to find the values, find the zeros, we call it zeros of denominator function, or in simple words, denominator. Find the zeros of denominator and exclude them. So x minus 3 into x plus 1, make it equals to 0. So you get x minus 3 equals 0 or x plus 1 equals 0. We get x equal 3 or x equal -1. And then you just need to exclude them. So -1 somewhere here, 3 somewhere here. So everything to the left, everything in between, and everything to the right. So the intervals are domain of f, -infinity to -1 union, -1 to 3 union, 3 to infinity. So remember, for a rational function means something over something. You just need to exclude the denominator. How about this example? How about, what if you had f of x equal x minus 3 over x plus 5? Now there are special places, right? So 3, f of 3, check this one, 3 minus 3 divide by 3 plus 5. So 0 over 8, that is acceptable because 0 over 8 is 0, a nice number. But f of -5, x minus 3, sorry, -5 minus 3 and -5 plus 5, -8 over 0. So you just have to get rid of the zeros of the denominator, not the numerator. So in this case, domain of f is all reals but 5, or another way of writing it down, all reals but -5, union -5 to infinity. Now, next, I'm talking about the tips, techniques here. Polynomials, everything. Rational functions, you just have to get rid of the denominator. And then we have next most famous thing. How about this? X plus 5. So radicals. If you have a radical sign, then what you need to do, see, this is square root of this. Now let's check some numbers. F of 0 plus 5, which is 5, that is nice. F of 1 plus 5, which is 6, good. So it seems like any positive number will work. How about negative numbers? F of -1, so -1 plus 5, which is 4, square root of 4 is 2, which is a nice number. F of -5, let's see that. -5 plus 5, which is 0, square root of 0, 0 is still good. F of -6, -1 square root, and they does not exist. So it seems like from some point onwards to the left, it does not work. So we cannot say it's that point is -6, because if you think about -5.5, that still gives us problems. -5.5 plus 5 is -0.5, which is C. So where do we start? Now, this is the tip. This is what you need to do. If you have a square root or any even root, this is only for even root, because odd root can be negative. Any even root, you take whatever inside the radical sign and make it greater than 0, and you solve this inequality. See, this is why we learned inequality. This is one reason why we learned inequality earlier. So x has to be greater than -5. So -5 here, or equal, because If it is equal, it can be 0 and it is perfectly fine. So domain of f is -5, this time including up to infinity. Now how about this? An odd root f of x, let's say 3. When you put 3 here, x minus 1, that means we are talking about 1/3 power of x minus 1. Now 1/3 power, well, for example, let's say f of -1. So when I put -1 for x, -1 minus 1, so -2. Well, so we are looking at this number, -2 raised to 1/3. In other words, you know what? In order to explain this, it's much easier if I choose some number that's easy to handle. So -7. When I have -7, f of -7, so -7 minus 1, which is -8. So -8. Now the question is, does this number exist? Or in other words, is there a number when you multiply itself 3 times? Some number times same number times same number, you get -8. Actually, there is -2 into -2 into -2. So this is -2. So odd roots, for odd roots, domain of f is all real numbers. You can, it works. Now, you'll understand this even better, much better, when we talk about graph of functions, and when we come to cubic root function graph, you will understand that. Now, to summarize, let me give you a simple table about. So we learned about polynomials, and we learned about rational functions, and we learned about radicals. Now, for example, some example here, rational functions are things like f of x equal 8x to the 9 plus, it can be any power. Let me just write down and stop there. And the domain of f, all real numbers for any rational. And for rational functions are things like whenever you have a denominator. See, let's make it 4. See, now here I have factorized it. Now the same thing, let me write it over here. X into x squared. What if it appears like this? X squared minus x minus 12. In this case, what you first need to do, factor it or solve, quadratic equation, right? Using quadratic equation, find the roots of this guy and then exclude it. So the technique we learned, exclude zeros of denominators. So in this case, negative infinity up to -3 union -3 to 4 union 4 to infinity. Finally, radical signs, for example, let's say x minus 5. In this case, as long as for even root, only for even roots, for even roots, make radicand or inside of the radical sign. So we call it radicand inside of the radical sign greater than 0. So x minus 5 greater than 0, so x has to be greater than 5. So domain of f 5 to infinity. So these are the techniques that you guys must use. You know what, let's look at a few more examples. Yeah, how about this example? F of x 1 over x squared minus 9. So what you need to do, take your denominator x squared minus 9, make it equal to 0 and solve it. So this is a quadratic equation. I can see factors, difference between squared x minus 3 into x plus 3. So x is going to be plus or minus 3. And then you have to omit those values. So minus 3 somewhere here, plus 3 somewhere here. So this region and this region. So domain of f is going to be negative infinity to negative 3 union 3, negative 3 to 3 union 3 to infinity. You know guys, when you are watching my videos, you may have to pause. You may have to please hit the pause button again and again and work with me. That's how you learn. And some tricky examples. How about this? F of x equal 1 over f of x equal 1 over x squared plus 1. Now this is a rational function. So again the same thing. X squared plus 1 equals 0. Quadratic equation. Remember, quadratic equation had three cases. It can have two roots, one root or no root. Now in this case, when you simplify, when you add 1 to both sides, you see x squared equal negative 1. This will never happen because when you multiply a number by itself, it is always positive. X squared is always greater than or equal to 0. So that means your denominator will be never 0. So you can definitely put any real numbers into this function. Please check it. Please check it with any real number. For example, f of negative 2. 1 over negative 2 parenthesis squared plus 1, which is 4 plus 1 and 1/5. See, it exists. That's a tricky one. How about this? F of x equal x squared minus 25. Now this one is actually little tricky because you need the help of a little bit polynomial inequalities. We did not cover that one yet, but let me show you how to do this. It's a little tricky one. So this guy must be greater than or equal to 0. Now this guy has factors x minus 5, x plus 5. So these two numbers, x equal 5 and x equal negative 5. So first the tip is actually, even though this is an inequality, first you make it equal to 0 because 0 is a special place and you look for those two values. Now take your number line. Again, I will be talking about polynomial inequalities in detail later. Now in this one, what you need to do, these two numbers, break your number line into three regions. Check with your favorite number. So in this region, let's say x equal negative 6. When I put negative 6 into my equation, what do I get? Negative 6 minus 5, negative 11, right? So negative, it's a negative number. That's all what it matters. So this part is negative. And x plus 5. So negative 6 plus 5, it's still negative, negative 1. Negative into negative, it's positive. So this region is okay because I need it to be positive, see. Next, anything in between, the easiest one is 0. So x equals 0. So when I put x right here, first part, 0 minus 5, which is negative, and 0 plus 5, which is positive, and negative into positive is negative, and it's not okay because I need positive. Next, over here, x equals 6, that's my choice. You can choose any number, x equal 5.5, x equal million, anything in this region. So 6 minus 5, first part positive, and 6 plus 5 again positive. So positive into positive is positive and it works. So it seems like we only have these two regions. So negative infinity up to negative 5, union 5 to infinity. That is our domain in this case. That's a little tricky one because it involves polynomial inequalities, and we'll do this thing again and again later. One more tricky example for you guys. It's not tricky actually, it's but let's make it 2. Square root of, let's say, x minus 5. Now what? Well, it's confusing because in our table, let me show you previous. In our table, where does it belong? Is it a rational function or is it a radical function? Actually, it's both. So, because first of all, because it's radical, you take this and make it greater than or equal to 0. So, x greater than or equal to 0. That's what you may think, but we have a problem. This is almost right, but almost not quite 100% because x equal 5, we had to get rid of that because it's in the denominator. So actually, how do you do that? This is a combination of rational and radical x minus 5 greater than 0. So 5 to infinity not including 5. For example, if you had f of x equal 2 times x minus 5 like this, then yes, greater than or equal to 5. In this case, you include 5 because 5 is now in the top, not in the bottom. So 0 is okay as long as it's on the top. But when it's in the bottom, you have to be careful there. Okay, guys, I think I did enough examples for domains. Thank you.